Okay, sequences in series. So a sequence is a function whose domain, which is just the set of x values, is a set of consecutive integers, which just means it's a list of numbers in a row. If the domain is not specified, then that means that we say that it starts with 1. So if I don't specify what the number is, then it starts at 1. And the values in the range are called the terms of the sequence. So we have two different kinds. We have a finite, and then we have an infinite. Finite just means that it stops. So I have 8 numbers or something in the sequence. And then an infinite means that it goes on forever. So that's what when I have the little ... That means that it goes on forever. So if we look at A, it's always going to give you a sort of formula. Each one is different. So it's not like I've had the question where they've said, are the formulas going to be on there? And this isn't a formula kind of thing. It's like every single question is different. So this is the specific type of sequence where n represents any number. So when we're doing a sequence, when you have that letter n, that means any integer, and you start with 1, then you plug in 1 for n, then you plug in 2 for n, 3, 4, 5, and you keep going, unless it specifies another number instead. So first term means that n equals 1. So when I plug in 1, I get 2 times 1 plus 5, which gives me what? 7. If n equals 2, then what would that number be? 9. If I plug in 3, 11. If I plug in 4, 13. Can anyone just tell me what the pattern is? What's the next number going to be? 15, 17.
Plus 2.
Yeah, so the sequence, the pattern is that it's adding 2 every time. For part B, now we have an exponent, so that makes it a little bit trickier. So for n equals 1, it's going to be negative 3 times 1 minus 1. So negative 3 to the 0 power, anything to the 0 power is 1. For n equals 2, I have negative 3 to the 2 minus 1. So negative 3 to the first power just gives me negative 3. For the third term, it will be negative 3. 3 minus 1 is 2, so negative 3 squared. Would that be positive 9 or negative 9? Positive 9 because of the parentheses with the negative 3. So then, fourth term, negative 3 to the third power. Negative 27, because it's an odd, so it's going to be negative. Negative 3 to the fourth power. 81, would it be positive or negative? Positive, because it's an even power. So an even power means that it'll be positive. And then sixth term would be negative 243. So you're raising it to the third power. So every single time you're multiplying it by 3. Or by negative 3. You knew it. You knew it. Okay. So let's look at the next one. For part C, now it just gives me a general formula, and it doesn't have the little blanks for first, second, third term. So we're going to have to actually write them out. So we are going to write the first 6 terms. So if it doesn't specify how many terms you want, then I'm going to say 6. But it should always specify how many. So the first term for this, if it's n over n plus 1, then when n equals 1, it would be 1 over 2. 1 plus 1 is 2. Y'all are so smart. What would the next one be? 2/3. The third term, 3/4. 4/5. 5/6. And the last one would be
7/8.
Nope, 6/7. The next one would be 7/8. You were just jumping ahead. Okay, so try part D, plugging in n equals 1 through 6. It'll specify how many it wants you to do. So in this case, we're saying 6, but it may say 5, it may say 4. Yeah, so this one, why are they all negative? So they are all negative because their -2 is not in parentheses. So for part B, it's in parentheses. So that means that with every odd power, it's negative. With every even power, it's positive. When it's not in parentheses, it's like saying -1 times 2 to the n-1 power. So this always stays negative. So when it's not in parentheses, your answer is always negative. So you should get -1, -2, -4, -8, -16, -32. Number 2, now they're giving us, it's like the opposite. So they're giving us the numbers, and then they're asking us to find a general formula or like a pattern. So you're used to finding patterns and things, but you've never created like a formula for it. So we're trying to find a pattern, and then we're creating a general formula using the letter n, like any term, that works for every single number. So when n equals 1, it's going to work when n equals 2, 3, 4. So what is happening between every number? So if I'm going from 1 to 8 to 27 to 64.
Add -7 multiplied by 3.
Can anyone see some sort of pattern?
Looks like you're multiplying by,
You think it's...
I don't think it's just like multiply by 3 and
multiply by 3.
subtract 4.
It has something to do with a power. So is there any sort of power? Like anything to the first power is always 1, right?
it's 8 to the 1/3.
Anything, so 8 to the 1/3, not the 1/3,
The third.
the third power. So you're always going to start with a to the n, or a sub n. That means any number.
That's very creative.
Then do you think it'll have a negative sign in front because they're all negative? Probably. And it won't be in parentheses. To the third power. And so with these, you kind of have to guess and check. Like there's really no proper way, I guess, to figure out what the pattern is without just guessing and checking. But in my brain, I always think I try powers, like to the first, to the second, to the third power. I'll try multiplying by something. Just guessing and checking will work for these. So whenever I have n equals 1, 1 to the third is always, or -1 to the third, -1. 2 to the third, 8. 3 to the third, 27. 4 to the third, 64. And then it wants us to write the next 3 terms. So in your calculator, 5 to the third, 6 to the third, 7 to the third. So what is 5 to the third power?
125.
125, and then you put a negative in front of it. 6 to the third, 216. 7 to the third, 343. Good. Okay, let's look at B. So this one is a little bit trickier. Do you see any sort of pattern of what's happening?
Is it going to be 20 next?
Is it going to be 20 next? Yes, it is going to be 20
So
next.
you're adding plus 2, plus 4, plus 6, plus 8, and then you do plus 10.
Right, so you're adding plus 2, plus 4, plus 6, plus 8, plus 10, plus 12. So if I were trying to use n's in my number, or in my formula, I'm going to have a to the n, or a sub n. If I'm starting with n equals 1, what times 1 gives me 0? 0. So like 0 times 1 gives me 0. If I want to get 2 as my answer, and I'm plugging in n equals 2, what times 2 gives me 2? 1 times 2, right? Then if I'm plugging in n equals 3, how do I get to 6?
2.
So 2 times 3. If I'm plugging in n equals 4, what times 4 gives me 12? 3. 3 times 4. So do you see any sort of pattern?
Times 1, times 2, times 3, times 4.
So 0 times 1, 1 times 2, 2 times 3, 3 times 4. So basically what's happening is the numbers are they're switching. So I have a 1 here, then the 1 moves to the left and I'm plugging in here. So my ends are always the right number. My ends are always the 1, 2, 3, 4. How could I create, using n, the number on the left?
N times n minus 1.
N times n minus 1, perfect. So the first number is n minus 1. The second number is n. So you have to be a little bit creative. So then what would the next number be? We said 20. So I added 8. Now I'm adding 10. So 30. Now I'm adding 12. 42. Good.
This is going to be difficult.
No. Okay, let's look at C. This is one of the hardest parts, is just creating it. So there won't be a whole lot of that. Let's look at C. And I'll give you a little hint. It has to do with powers. So to some power. Everything squared. Good. Because it's like 1 squared, 2 squared, 3 squared, 4 squared. So what's 5 squared? 6 squared? 7 squared? Good.
I keep thinking, like, what's the pattern between those numbers, not like, you know what I'm saying?
Yeah. Okay, this D, I want you to try this one on your own. This D is very similar to part B. Something very similar. So think about when n equals 1, what do I need to multiply it by to get 3? 3, so 1 times 3. When n equals 2, 4. When n equals 3, 3 times 5. When n equals 4, 6. Good. So my first number is n. So a sub n is n. Then my second number is n plus what? N plus 2. Because the difference between 1 and 3 is 2. So what would the next one be? It would be 5 times 7. 35. 6 times 8. 48. 7 times 9 is 63. Okay, so what we looked at earlier was finite series. These are infinite series. The only difference is that now you have this sigma, this uppercase sigma, which we call a summation. Summation, which just means that you're adding it together forever, okay? So it's like it never ends. It's not like you're finding the first 6 terms. You're finding the terms and they go forever.
Oh, so that's what we use the ...
Yes. So the difference between the finite series and the infinite series is that this number right here will be a specific number like 4. So you're going to the 4th term if it's finite. And it'll have an infinity sign if it's infinite, okay? So it'll have a number on top if it's finite. It'll have an infinity sign if it's infinite.
So the ... and the infinity sign.
Yeah. So the ... and the infinite sign. Infinite, that's not how you spell it. Infinite, that's fine. Infinite and ... same thing. So we are going to look at part A for number 3. We're going to write a series using summation notation. So it ends at 250, so it doesn't go on forever. So that means that I'm going to have a number on top. So I'm going to put my sigma. You can draw it as best as you can. It's going to start at, you'll notice both at the bottom, I equals 1. You use the letter I. That just means my starting point, like n equals 1. But we use the letter I when you have summation notation because a Greek mathematician said so. So I'm going to put I equals 1. We're starting at 1. We're starting at 1. What is happening between every number? I'm adding 25, or I'm multiplying it by 25, right? Because 25 times 1 is 25. 25 times 2 is 50. 25 times 3 is 75. So, in parentheses, I'm going to put 25 times I. So all I'm doing is I'm replacing in with I. When you have a sum, you use I. And then 250 is going to be my last term. So what number goes on top of the sigma? 25 times what gives me 250? 10. So I'd put 10 at the top. So it's like I'm going from 1 to 10. So when I equals 1, it's 25. 25 times 1 is 25. 25 times 2, 25 times 3, 25 times 4, 5, 6, 7, 8, 9, all the way to 10. 25 times 10. So it's like when I plug in a number for I, I'm getting the answer. And it stops at 10 because 250 is my biggest number. Okay, for part B, is it going to be infinite or finite? Infinite. So I'm going to draw my little sigma. I'm going to put I equals 1 on the bottom, and I'm going to put an infinity sign on top. So if I look at the pattern, the top is always increasing by 1, right? And the bottom is also increasing by 1. So what could go on my numerator? 1. It's going to be in like a letter, so I'm going to use I. So I goes on top. So when I is 1, I have 1 on top. And then I plus 1 on the bottom. Good. Good.
So it's I minus -1. Oh, you're even more.
Or you could put the whole thing in parentheses. Okay, let's look at C. Infinite or finite? Infinite. So I'm going to put infinity on the top. So I have the sum. I equals 1 to infinity. So like if you think about it, and then when you have your sigma, the bottom is your lower bound and then the top is your upper bound. And if it goes on forever with the dot, 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 then you put it in infinity. If it stops at a number like it did on A, then you put whatever that x value is, like whatever that number is. So it stops at 10. I only go 10 terms. So it's going to go forever. If I look at the first, second, third term, what is happening? It's getting multiplied by something. By 6.
6 times that was 1.
So it's getting multiplied by 6. 6 times 1 is 6. 6 times 2 is 36. So it would be 6i just being multiplied. It's not a power.
You mean 6 squared?
Or 6 to the I. I'm sorry.
Thank you.
6 to the I. Somebody said that. To the I, because it's like 6 to the first power, 6 squared, 6 to the third power, 6 to the fourth power. Okay, part D. Is it infinite or finite? Finite, so I'm going to put I equals 1 at the bottom, and I don't know how many terms yet. We're going to look at it numerator and then denominator. So we're going to look at the top first. So what is happening to the top? 1, 4, 9, 16. What's happening? Yeah, so like the first one is 1 squared. The second one is 2 squared. The third one is 3 squared, 4 squared. All the way, what is 49? 7 squared. So I'm going to put a 7 at the top because I know that it stops at 7. And then on my numerator, it's going to be what squared? Like what is the letter or the variable that we use? I. So I squared. Then what do you notice about the bottom? So it's always like the number on the bottom compared to the top is always what?
I squared plus 1.
It's always bigger. It's always bigger by 1. So like I have 1 over 2, 4 over 5, 9 over 10, 16 over 17. So it would be I squared plus 1. Good. Okay, so for part A, now it gives me the summation, and it's wanting us to solve. So looking at part A, it is finite. What number does it start at? 4. You'll notice that they use a K there. It doesn't have to be an I, it can be any letter. So whatever letter they put there, it just has to match with the letter that they put in the formula. So I could use N, I could use K, I could use F, I could use P. It doesn't really matter, any letter. So I'm going from 4 to what number? I'm going from 4 to 8. So I'm going to plug in 4, I'm going to plug in 5, I'm going to plug in 6, I'm going to plug in 7, I'm going to plug in 8. So when I plug in 4, it's going to be 3 minus 4 squared. Oh, it's a plus, sorry. 3 plus 4 squared. So what do you get when you plug in 3 plus 4 squared? 19. When I plug in 5, and I'm adding all of these because that's what a summation is. So you're adding all of these together. So then it would be 3 plus 5 squared, which would be what? 28. Plus 6, so 3 plus 6 squared is 39. And then 7, 3 plus 7 squared. And then my last one is 8, so 3 plus 8 squared is 67. So then in your calculator, you will add up 19 plus 28. You'll add all of these together. And your total sum, so the sum of the series, if you plugged that in, you would get 205. So try part B on your own. You're going from 3 to 7. 130 if you're just adding it from 3 to 7. And then lastly, so here are the formulas for special series. You will be given these. We're just learning how to plug them in. So yeah, you're going to be given the formulas. Just need to know how to plug them in. Right, so if you have where it's just 1 right here, like if it's just a 1, then your answer is the number that is on top.